Now, for tonight's C, we are discussing lifestyle changes linked to slower brain aging before 70. Okay, here we go. The brain does not age on a fixed schedule, it ages in response to the lives we lead, our movements, our meals, our sleep, our relationships, our work, our stress, our environments before 70, before age 70. These choices can slow measurable brain aging by years, sometimes even by decades. This is not a wellness slogan. It is one of the most consequential scientific findings of the last 20 years, reshaping how we understand aging, dementia, and the future of long term care. It reframes it reframes the brain not as a passive organ drifting toward decline, but as a dynamic, adaptive system, one that responds continuously to the conditions of our lives. The old story, decline has destiny. For most of the 20th cent- for most of the 20th century, cognitive decline was treated as a biological fate. The brain was thought to follow a predictable arc, peak in early adulthood, slow erosion through midlife, and accelerating loss after 70. Dementia was framed as a tragic but unavoidable outcome of longevity, a kind of neurological tax paid for living long enough. This narrative shaped everything from clinical practice to public policy to cultural attitudes about aging. It justified underinvestment in prevention, reinforced fatalism, and left families and health systems bracing for an inevitable wave of cognitive loss. But the science has changed, and with it, the moral and policy landscape of aging. The new story: brain aging is modifiable. Give me 1 second. Researchers now show that brain aging is not a passive process. It is shaped by three biological systems that remain remarkably responsive to lifestyle choices well into late midlife. Inflammation, chronic low grade inflammation. Inflaming accelerates synaptic loss and white matter damage. Vascular health. The brain depends on extinguishingly regulated blood flow, stiffened arteries, and endothelial dysfunction, starved neurons. Metabolic stability. Neurons require clean, efficient energy. Insulin resistance and mitochondrial decline impair cognition. These systems are not fixed. They respond, sometimes dramatically, to changes in behavior, environment, and psychology. Physiology. Lifestyle choices influence all three simultaneously. Something no single drug has yet achieved. This is the quiet revolution. The biology of aging is more malleable than we ever imagined. The lifestyle factors that slow brain aging. Below are the interventions with the strongest evidence. Each begins with a guided link so you can explore the science behind it. Aerobic exercise increases hippocampal volume, improves executive function, and reduces dementia risk by 45%. Movement enhances blood flow. Stimulates neurogenesis and reduces inflammatory cytokines. Strength training releases anti-inflammatory cytokines and improves insulin sensitivity. Muscle is metabolically active. It stabilizes glucose and supports vascular health. Mediterranean style eating Polyphenols, omega-3s, and fiber reduce inflammatory cytokines and support vascular integrity. Diet shapes the microbiome, which in turn influences inflammation and cognition. Sleep optimization. Deep sleep clears metabolic waste through the glymphatic system. Poor sleep accelerates amyloid accumulation. Sleep is the brain's nightly housekeeper. Cognitive challenge. Learning new skills strengthens neural networks and builds cognitive reserve. Novelty forces the brain to adapt, creating redundancy and resilience. Social connection. Loneliness increases dementia risk as much as smoking. Social engagement reduces stress hormones and supports neural resilience. Human connection is biologically protective. Vascular control, vascular risk control, managing blood pressure, cholesterol, and glucose is one of the most powerful ways to slow brain age. The brain is a vascular organ. Its health depends on the health of its vessels. These are not fragile inventions. They are grounded in decades of research across neurology, epidemiology, and geoscience. The measurable impact. The numbers are not subtle. People who adopt multiple protective habits by age 60 slow brain volumes, show brain volumes 5 to 10 years younger than peers. Anti-inflammatory diets lower risk of mild cognitive impairment by 30 to 50%. Sleep quality predicts cognitive aging more strongly than genetics. For many adults, social engagement reduces dementia risk by up to 30%. Midlife exercises reduce Alzheimer's risk more than any currently available medication. These are population level effects, large enough to shift national dementia curves. They suggest that the future of cognitive health will be shaped not only by biomedical innovation, but by the environments, policies, and cultural norms that support healthier living. Why The window before 70 matters. Before before age 70, the brain retains enough plasticity to remodel itself in response to healthier inputs. Synaptic networks remain flexible. Vascular systems can still adapt. Metabolic pathways can still be stabilized. After 70, lifestyle still helps, but the slope of change is steeper, and the biological systems involved are less flexible. This makes midlife a policy critical intervention zone. It is where health systems, employers, and communities can meaningfully alter the, the trajectory of cognitive age, cognitive aging. It is where prevention is most biologically patient and most economically impactful for health systems already strained by rising dementia prevalence. This window represents an opportunity to shift from reactive care to proactive prevention. The health system implications for someone in your world: palliative care, health systems, leadership, long term care reform. The implications are profound. Delaying cognitive decline delays care needs, reducing pressure on long term care facilities and home care systems. Lifestyle interventions are low cost, scalable, and equitable, especially when embedded in community infrastructure. Brain health promotion should be a core public health strategy, not an optional wellness add on. Midlife prevention reduces late life suffering, aligning with palliative care's echoes of dignity, autonomy, and meaning. Workforce and employer policies matter. Flexible schedules, movement friendly workplaces, and stress reduction programs are cognitive health interventions. Community design matters. Walkable neighborhoods, green spaces, libraries, senior centers, and dementia prevention tools. This is not just this is not just about adding years to life. It is about adding clarity, independence, and selfhood to those years. A narrative from a narrative frame for public audiences. Brain aging is not a fate, it is a trajectory shaped by choices, environments, and policies long, be- long before symptoms appear. The most powerful interventions are not futuristic drugs, they are everyday habits that strengthen the brain's resilience decades before we need it most. This reframes aging from decline to, stewardship, from inevitability to agency. It invites people and policymakers to see brain health as something cultivated, not simply inherited or lost. Slower brain, slower brain, slower brain aging before 70 is not a miracle. It is it is biology responding to care. When people move their bodies, nourish their cells, sleep deeply, connect meaningfully, and manage vascular risk, the brain the brain ages more slowly. These choices accumulate, shaping neural architecture in ways that determine whether the final decade of life are marked by clarity or confusion, independence or dependence. Inflammation in aging. A clear evidence based long form essay with biological depth and policy relevance. The core idea, a slow burn, a slow burn that shapes how we age. Inflammation in aging, often called inflaming, is a chronic low grade activation of the immune system that emerges as a hallmark of biological aging. It quietly accelerates tissue damage, frailty, and the progression of nearly every major aging related disease, from cardiovascular disease to diabetes to dementia and cancer. Unlikely, unlike the dramatic, short lived inflammation we see with infection or injury, redness, swelling, fever, inflaming is a slow burn. It is it is sterile, not driven by microbes, persistent and subtle. You don't feel it as a single event. You live inside it as a background condition. Over decades, that background becomes loud enough to distort the entire system. For a health system lead, for health for a health system leader thinking about long-term care, dementia trajectories and palliative pathways, inflaming is not an abstract concept. It is the molecular infrastructure beneath the surge in multimorbidity, cognitive decline, and functional loss that's that shows up in your clinics, hospitals, and nursing homes. What inflaming actually is, the biology under the word chronic low grade immune activation. At its core, inflaming defined by persistent elevation of pro inflammatory signals, cytokines such as IL-6, TNF-A, IL-1B, and biomarkers like C-reactive protein, CRP. These molecules are meant to be transient messengers, raising briefly to coordinate defense and repair, then falling once the threat is resolved. In aging, they never fully quiet or quit. This chronic signaling affects a dysregulated immune state. Immune cells composition shifts. More sensory exhausted and pro-inflammatory cells, fewer native adaptable ones. Regulation, resolution of inflammation falls. Off, the off switch becomes weak. So minor insults trigger prolonged responses, damage associated molecular patterns or DAMPs, fragments of damaged cells and proteins continuously simulate an innate immunity. The result is a body that behaves as if it is under consistent low level threats. Immunoscience and inflaming twin processes. Inflaming is tightly intertwined with immunosense. The age related decline and recognition of immune function. As the immune system ages, it becomes less effective at clearing infections and malignancies, yet more prone to chronic inflammatory signaling. Key features include thymic involation. The thymus shrinks, reducing output of naive T cells and narrowing the T cell receptor. Hippocamp, hippo, hempa, hem, hematic proteinetic stem cell drift, stem cell skew toward myelin, myeloid lineages, increasing pro-inflammatory cells at the expense of adaptive ones. Accumulation of late differentiated pro-inflammatory T cells such as CD28 and T temra cells, which secrete cytokines but respond poorly to new antigens. Immunoscience and inflaming form a self reinforcing loop. Declining immune precision leads to more chronic inflammation, which in turn further damages immune cells and tissues. Where inflaming comes from, covering drivers. Inflaming is not caused by a single defect. It emerges from multiple overlapping processes that each add a small but meaningful contribution to the body's inflammatory tone. As cells accumulate, DNA damage, and stress, some enter a state called cellular senescence. They stop dividing but refuse to die. Senescent cells secrete a cocktail of inflammatory molecules known as the sense associated secretory phenotype SASP, IL-6, IL-1B, TNF-A, cytokines, and proteases. These signals recruit immune cells that may fail to clear senescent cells alter the behavior of neighboring healthy cells. Propagate inflammation locally and systematically. Over time, senescent cells become micro factories of inflaming scattered throughout tissues. Okay, guys, that is your C for tonight. I will be back on with these shortly. For now, Gator Wellness. Take care, folks.